Well, thanks, Pat. Thanks, everybody. And as Pat said, I'd really hoped to get to speak here last year, but couldn't make it. Got a lot to present, so I'll try and drone on. Actually, so I guess somebody, one of the guys from FAA described themselves yesterday as a recovering federal employee. I consider myself a feral federal employee. So I have to say, when I'm talking about NOAA's requirements for data and what we've done with UAS, that's the truth. Everything else I talk about is going to be my personal opinion and is not going to reflect necessarily, the agency's position. So you're just getting my perspective from about 10 years of being involved with this industry and with equipment. So I'm going to talk quickly, kind of brief overview, the prehistory of, how we got to where we are today, what we've been doing, what we would like to do, how we think maybe the commercial market can support us in a couple different ways. Maybe there'll be some time for discussion at the end. So you've seen versions of this slide at every UAS show you've ever gone to, but I just want to highlight where it's different for NOAA. I mean, we're a federal agency. We study the ocean and the atmosphere. All the seals and sea lions and whales are part of the domain of things we're responsible for studying and surveying. We go to really, really remote places, from the Arctic to island archipelagos all over the Pacific. And we found that UAS, especially small UAS, really allow us access into these sort of beyond the dirty, dull, and dangerous, which is incorporated into a lot of what we do. Sort of this denied access, places you can't get to otherwise, and from an environmental standpoint, allows you to operate in areas where you're less likely to disturb the organisms that you're trying to survey. You send a small electric UAS out, you don't have to be concerned with landing people through the surf in a remote atoll, hundreds or 1,000 miles away from medical help. You don't have to worry about introducing exotic organisms into a pristine environment because you're not going there. So there's a lot of reasons that they're really good for us. Of course, the stealth allows us, again, as I said, to not disturb things, and you get a persistence that people don't often think about. Where you could stay on top of whales all day long, where a helicopter is going to beat up the water surface, maybe disturb the animals, and have to go back and get gas every couple of hours. Where with a small UAS, swap out the battery or have one on standby, you could stay on top of something all day long and get helicopter or better quality imagery. So there's a lot of things you can do that I think haven't been done before with manned aircraft. So we started off in 2005 in a partnership with NASA flying Altair, which was a pre-production Predator B. We're still working with them on the larges, both on the Global Hawk, which is not shown, and Icana, which is the NASA MQ-9 Predator B, and I'll be actually running a deployment out in Hawaii this summer where we're going to fly out into the remote Pacific using that platform for science and fisheries monitoring. But we tested a lot of small systems too. You saw the Manta, which is one that we have a couple in inventory that we're not using much anymore. Working with NASA, we launched an Aerosonde into a hurricane in, I think it was 2005 or 6. We played around with a Scan Eagle. We've deployed on a NOAA ship in the Arctic, surveying for sea lions. And despite what Pat might have said yesterday, I think there may be actually a niche for that system in our work because we go so remote. And really the holy grail for us is being able to launch and recover at sea. I mean, that's how we get there. So we may be at a place that takes 2 weeks to get there, and we got 25 crew and 25 scientists, and it costs more than $50,000 a day to be there. So it's okay for us to spend a little bit of money on a system if it really works. We've fooled around with quadricopters too. We have several in our inventory. They've quadricopter multicopters and seem to be pretty interesting for getting super high resolution, say, of bird colonies, imagery that's beyond what we can get with a wing type UAS. However, the battery power and flight time restrictions, especially within the COAs that we've been getting, have rendered them pretty not useful to date for us. For example, the COA, for last summer's work off the Washington State outer coast for seabird work, we had the biggest battery we could get for our MD4-1000 was a 40-minute battery, but we had to have 20 minutes of reserve time on it. So we can only can't get very far offshore and do much work and come back in 20 minutes. So they may, as battery technology evolves and possibly airspace, they may become more useful. So after studying a whole lot of systems, we went and bought 2 Puma AE DDL systems from AeroVironment about 3 years ago, and have been working the last 2, this will be our 3rd field season, developing and perfecting the protocols for various types of natural resource missions that we use them for, including counting critters, emergency response for oil spills, which is probably one of the killer apps, or early tactical phase oil spill quantification and tracking, enforcement, fisheries enforcement, especially at night. Pretty great technology for that. It's part of the big puzzle of finding giant lost fishing nets in the middle of the ocean. And we took a system up to the Arctic with the Coast Guard last year, and that's another area where I think UAS, shipborne UAS, probably have a future in science and operations for the government. So the Puma has been good for us because, as I said, operating at sea is where it all comes together. And we've made some adaptations to the out-of-the-box system, exploited some that it comes with, including in the lower right, the sort of hand controller, which is part of the ground control system. You can have multiple screens that are deactivated hand controllers, essentially as remote video terminals, and those can export out to other monitors. And so we both put those on launches, and I have some pictures coming up showing how we helped scientists tag blue whales by doing this. And we've also used this for enforcement, allowing boarding parties to have more situational awareness, before they climb up onto a boat at night that's got lights shining down in their eyes. And we've tapped into that and used big TV monitors, gamer goggles. I mean, we've made all kinds of adaptations to allow the scientist to be directly engaging with the UAS operator about where the payload is and where they want the images collected. But hand launched, recovered in the water, it actually works, so that's a big deal for us. Just to get a shot of, export out in the cabin of a boat. So there's a recovery at sea on a not so decent day. And those are the kind of conditions we operate into. So at about 25 knots, that's where it all goes to hell, basically. So that's where it's no fun to have a small boat in the water. It's where the quality of the data starts to degrade a little bit. And that's really what we've observed. It's hard to collect quality imagery above 25 knots with a small UAS. So we put together a lot of experiments and analogs. This slide's showing some simulated monk seals and sea turtles out in Hawaii, some marine debris work that we did following the big Japanese tsunami. And the first step for us is figuring out, can you even image it? If you can image it, then the next step is, can you find it? But we worked around the country testing and demonstrating what you can actually do, with the systems that we have that fit our mandates. I hope this is clear enough for you because it's an amazing photo. And this is just sort of one really neat way to sort of talk about what you can do with small UAS that you couldn't do with a manned plane. So people in this orange inflatable have a suction cup tag at the end of a pole. And what they're trying to do is put the tag adjacent to the dorsal on the back of this blue whale, the biggest animal that's ever been on Earth. And so the people without running the whale over, that is. And so the whale's breathing and surfacing, and the people in the rib boat are kind of standing by and trying to get right there so that they can motor right up to it, but not on top of it, get that tag on, and back away before the whale dives again. And so by putting one of these remote video terminals on that rib boat, we were able to have the Puma on top of the whale, allowing them to see when the whale's going to surface next while they're driving the boat to actually apply the suction cup tag. They can also use that known scale of that 20-foot long inflatable to figure out how big the whale is and verify that the tag was accurately and securely placed, and save sometimes hours in the process. Because getting that all synchronized is really, really difficult. So it makes it all more efficient, less stress on the animal, saves us a ton of time and gas money. Just one of these sort of amazing things that we've realized that we can do with these systems out in the field. So surveying for whales, surveying for seabirds, which we've done both with the multi-copters and with the fixed-wing UAS. Sea lion surveys, these are actually just California sea lions off the coast of California on one of the Channel Islands. But this mission was an analog building to a northwestern Hawaiian Islands deployment that'll be going on one of our NOAA ships 500 miles offshore next month. So we've developed these protocols, as I've said, in less remote places so that when we go remote, we know what we're doing. We know the equipment will work. We also have requirements for habitat mapping, and I think I stole the digital elevation map, the LiDAR map on the lower corner, but sort of state of the art of where we are now and where we want to be. And I'll talk a little bit more about that in a second. We went over that slide, really. So the Arctic, really interesting place to operate, very challenging environment. We're talking about a place where the compass spins like the Bermuda Triangle. You deal with wing ice, LCD panels freezing, no DTED. So it's definitely a challenge. We had a very successful deployment last year on the Coast Guard icebreaker Healy. And one of the takeaways from that, which was really interesting, was that we're still don't have flight clearance to land on the deck of a ship. So the real danger became putting people down in small boats to recover the Puma. We're actually taking people off the icebreaker and putting them in the ice water. So we're working on that for next year, this summer actually, with AeroVironment, with a new net capture system that we can hopefully see fielded this year that'll reduce that risk and then allow us to be able to collect data. And this was really, this experiment here was all about oil development and threats to the environment for the future, because as we all know, there's exploration going on in the Arctic right now, and global climate change is allowing the fabled Northwest Passage to open, and commercial ships are daring their way through there. And so it's inevitable that there's going to be a catastrophic discharge of oil in the Arctic, and we're just trying to figure out now, NOAA and the Coast Guard really, how we can image, quantify, and clean up oil on the ice, under the ice, in the slush. And so this is part of it, but a lot of this is really applied in figuring it out as we go. One tragic note, while we were deployed last year, and one of the things we were doing with the Puma was getting out in advance and finding cleaner routes through the ice fields for the icebreaker so that they didn't have to go around or crash through so many ice ridges. On a Canadian icebreaker in a different part of the Arctic, but while we were deployed, had a helicopter go down 10 miles in front of the icebreaker. The icebreaker's captain, the helicopter pilot, and the chief scientist for the trip were lost. They got to them. They were still floating in their float suits, but it takes an hour or two to go 10 miles. So it was too late for them. So this shows how these systems can really be deployed in remote areas to reduce risk for humans. I mentioned enforcement and one of the killer apps. I'll talk a little bit more about why we can't use it yet for enforcement, but we sort of why we can't apply it due to sort of policies in a couple levels. But fisheries enforcement is really a neat place to go with this. So I'd say our successes are that we really understand launching and recovering at sea from vessels really of every scale, from small boats as much as like 7-meter long rigid hull inflatables to big ships and research boats, everything in between. We understand how to operate, how to do different types of natural resource survey missions, collect the data, interact with scientists, with the vehicle operators. We've even operated from the shore. We've kind of figured out airspace. We've got COAs all over the country now that allow us to go back and operate within certain conditions, not with a lot of spontaneity though, and I'll get back to that. And there's a new MOU that we have with the FAA for airspace for small UAS. It's similar to one that the Department of Interior and NASA both have. And it has some utility, but it's pretty limited still in what we can do. And I'll talk a little bit about that towards the end. But I really think we've established ourselves, NOAA, as an agency, as leaders in using small UAS for marine resource monitoring, and we're happy to share. So where have we done like this enforcement work where I get 12, 15 miles away from the ship so that we can be stealthy? Where have we developed a lot of these protocols? In military warning areas. So as a federal agency, we're able to coordinate and schedule whiskey areas, warning areas, and restricted areas, and fly beyond visual line of sight. And so lucky for me is off the coast of Southern California, there's a Point Mugu Sea Range, the Channel Islands National Marine Sanctuary is right in the middle of that. So we have NOAA scientists, we have research vessels. We're able to work in these sort of greenish areas by scheduling them with Point Mugu. It costs money, but when the whiskey area is hot, they've got their radars running, we can actually test and use systems to their full capacity. So we're learning how to operationalize things that we can't actually do in practice yet because of airspace restrictions. This has been, we've done this all over the country. We've scheduled warning areas, off of Georgia, Florida, Hawaii, California, Texas. So that's how we've been sort of getting to and trying to stay at the bleeding edge of this. So today, someone comes to me in the agency and they say, okay, I want to use a UAS for this mission. The first thing I really say to them is, okay, why? And I want to figure out, one, because I'm realizing our COA, most places, probably isn't going to allow them to fly beyond the visual line of sight. So, my first sort of snarky response is, can you just do it with binoculars? So my second one is, maybe you ought to think about just renting a Cessna. And not because I'm a big believer in UAS and small UAS, and I think there's a lot of things that can be done better, and eventually better, cheaper, and faster. But we're not quite there yet. So we're not operational in too many places for too many things yet. Again, because of rules rather than capabilities. And last year, on a back of the envelope calculation, I realized it was taking us about 80 man-hours of administrative stuff before we flew our first hour, for every mission we were doing. And that's, those are repeat missions. It goes down a little bit. A new mission, obviously, there's more hassle, more people you have to convince that have to understand what you're trying to do. That's getting better now, and the MOA COA that we have with the FAA reduces that time again, but it's still a significant amount of time. And again, back to spontaneity. You have to plan a long time in advance, really, to do a UAS op. So, their highest utility for a lot of these things is going to be that they're available and they're on scene, and you can go get great high-def imagery with the telemetry and everything right there. So my last point here, UAS are not better and faster or cheaper yet. Now, I'm going to remove better. I'm going to say they're not faster or cheaper yet. So what do I want as a customer? Okay, if I'm buying data, I want services that are competent and affordable, and I want data and products that meet my specs. Pretty simple. If I am buying equipment, I need systems that are documented and certified. They come with training. They come with spares, right? Repair services, and high volumes of everything. I need the stuff to work, and I need to be able to keep it all in working condition. So requirements for scientific and commercial market. And this is where I think, the work that we do is representative, at least of the science market and maybe some of the commercial aspects. Again, documentation and certification. We bought military certified stuff so that it would be easier to get access to the NAS, to the National Airspace. We paid more for it, but it makes sense for us. I want a single operator. I don't want, back to the cheaper part, I don't want two people to have to operate if it can be done with one. Simple user interfaces. You know, it'd be great if you could learn to operate something in a couple days instead of 10, say. And I really think the industry has to think about developing generic payloads on spec. Some payloads that will have universal applicability, LiDAR, multispectral. I mean, there's companies doing all these things, but you know, the integration into some of the systems. And that gets to the whole sort of, are you buying, is it a flying camera? Or is it a small pickup truck that carries different things? And you know, that's a whole discussion that you can have. But there's certainly some payloads that we would like to fly that we can't yet to get to the digital elevation maps and some of those things. And that gets to the whole, you know, do we buy a bunch of special purpose UAS, break it out of the box, define 4 corners and throw it and it comes back with a digital elevation map? We, because of our COAs, because we're a federal agency, I've got actually winged pilots flying our UAS. So the guys that fly for us fly Twin Otters, Gulfstreams, you know, whatever for the agency. And so I can't justify keeping them proficient on 10 different systems. You know, so for us, I'd like a solution where, you know, pop and play on the payloads so that we can go everywhere we need to go and do everything we need to do. But it may evolve depending on the small UAS rules, and if we eventually allow scientists to operate systems on their own, we may start authorizing small UAS being operated by users. So again, areas for development, in my opinion, simple user interfaces. I think Gabe mentioned this. Pat talked about sort of easy button interfaces to quickly ingest data into GIS systems. I want to not have to deal with proprietary software in between. And I think we need some advances in compression technology to push more higher resolution through the pipeline. And whether that's line of sight, or I was at Google a couple weeks ago, and the whole Google Loon concept is fascinating. You know, that there may be these high altitude UAS beaming down Wi-Fi to remote parts of the Earth. So if you don't have the penalty of carrying around satellite communication equipment, you could have a small system really sending real-time data a long way back. I'll skip through this latency of data thing because it's not a huge thing and get you to my last couple slides. So the technology's ahead of the rules. I think we all kind of understand that. The other challenges, I think, besides the lack of spontaneity, are lack of dedicated bandwidth for, you know, payloads. If you're out in remote areas, it's okay probably if you use common, you know, 900 megahertz, 2.4 gigahertz, because you're not going to get stepped on. But if you're operating near civilization, that's an issue. I think the bureaucracy domestically is actually expanding. It's getting harder to do things, not easier, and I've been doing this for 9 years. I think the uncertainty associated with the timing and what the rules are going to be of the FAA's new small UAS rules are holding this industry, you know, below an inflection point. Political concerns and public perceptions are keeping us from doing enforcement work. It's the killer spy drone thing, even though I argue that commercial fishermen have no assumption of anonymity, you know, in their work. That's why there's giant numbers emblazoned on their roofs of their boats. We can't do that right now because the political concerns about the public perceptions and then our own policies related to that. So what do? I mean, people are developing wonderful things, but they can't be fielded a whole lot in the US right now. So the risk of you know, your new payload or system becoming obsolete before it really gets a broad market, it's a big risk. Whether or not companies are looking at volume and you know, being able to really sell a lot of units to bring the unit cost down, or whether it's the DoD model of rate of return on your investment, you know, you kind of have to think about your business model. And remember, it's always easier to get leapfrog, you know, someone else to look at what you're doing and pull the next thing out. So the timing's difficult. Last slide here. That's our FAA COA by MOA. Below 1,200 feet for small UAS, 5 miles from an airport, not overpopulated areas, 24-hour notice. So I don't know if that's a peek over what the new US rules are going to look like. But whatever it happens, however much the space opens up, there's going to be market forces at play. There's going to be some consolidation in the industry. I think some companies may be acquired for their anomaly detection algorithm or what have you. You know, but I don't know that market's going to be big enough for everybody, to make overlapping devices and systems. But I think there's going to be a big potential for people who are in the right place at the right time. So good luck playing it. Thank you.